So we're trying to find the volume of H2O needed in order to make the pressure in the vessel, the total pressure in the vessel, equal to 2 times the pressure due to mercury. If we can define the volume of the H2O as the cross-sectional area times the height of the water needed in this particular vessel. We also know that the cross-sectional area is equal to 12 square centimeters. The height of the mercury is 8 centimeters. Further define this height. And then we can say that the pressure due to mercury is simply equal to the gauge pressure due to mercury is simply equal to the density of mercury times the acceleration due to gravity times the height of the mercury. We can further define the pressure of H2O as the density of H2O times the acceleration due to gravity times the height of H2O. And again, seeing this, we can know that this value right here is what we need to find, because this value is what we need here. So we know that the total pressure is equal to the pressure of mercury plus the pressure of H2O. And we need the pressure of H2O to equal the pressure of mercury. This is because once the H2O is added, the total pressure will be equal to 2 times the pressure due to mercury. So the pressure of mercury must equal the pressure of H2O. Plugging in for our constants, we find that the density of mercury times the acceleration due to gravity times the height of the mercury equals the density of the water times the gravity times the acceleration due to gravity times the height of the water. Here is what we're trying to isolate. We're trying to isolate this variable. We can cancel out the g because they're on both sides. And we have that the height of the H2O is equaling the density of the mercury times the height of the mercury divided by the density of the water. The density of mercury is 13.6 times 10 to the third kilograms per cubic meter. And then the height of the mercury, here we can use 8 centimeters. Our cross-sectional area is in centimeters and our height is in centimeters. We're also using densities of the same unit. So the density of water being 1,000 kilograms per meters cubed. So as long as the dimensional analysis works out, we don't have to convert this into meters always if we're keeping centimeters constant throughout the entire problem. So solving for this, we find that the height of H2O, and again, we use centimeters, so the answer will be in centimeters, is going to be 108.8 centimeters. We know that the volume of the H2O is equaling the cross-sectional area times the height. So the volume of H2O needed is going to be simply 12, the cross-sectional area, times 108.8. And this is going to equal 1,305.6 cubic centimeters. So in order for the total pressure to be twice the pressure due to mercury, the pressure of the water needs to be equal to the pressure of the mercury. And in order for that to occur, a volume of 1,305.6 cubic centimeters of water must be added to this vessel. And that's the end of the solution. Thank you for watching.